Section 7.6, Radical Equations. Our first and only objective is to solve them. So to solve radical equations, isolate the or a radical. Sometimes we have two. Raise each side of the equation to the power of the index. So if the index is 2, you square both sides. If the index is 3, you cube both sides. If the equation still contains a radical, you repeat steps 1 and 2. So when you have two radicals in your equation, you need to do steps 1 and 2 twice. Then you can go ahead and solve, and you must always check your solutions. There's so many times in radicals that you have extraneous solutions, and you'll see that today. So example 1, we want to solve the square root of x plus 1 equals 5. So since we already have a radical by itself, we're going to square both sides because the index is 2. So we have x plus 1 equals 25. Subtract 1, we have x equals 24. Now we need to check our answer. This one's not hard to check. We plug it in, we have 24 plus 1 equals 5. So the square root of 25 equals 5. It indeed does. So it is a solution. Example 2. We need to isolate the radical. It's not by itself. So in order to isolate it, we need to move over the 1. So we have the square root of x minus 1 equals 1. Now we're going to square both sides because the index is 2. So we have x minus 1 equals 1. Add 1 to both sides. So we have x equals 2. Now we need to check our answer. So we have 2 minus 1 equals 0. So 2 minus 1 is square root of 1 minus 1 equals 0. The square root of 1 is 1. And 1 minus 1 does equal 0. So 2 is a solution. Alright, example 3. We need to isolate the radical because it's not by itself, so we're going to subtract 2x. So what we're left with is square root of x plus 1 equals 8 minus 2x. You could also have negative 2x plus 8. And now we need to square both sides because the index is 2. So we have x plus 1 equals 4x squared minus 64x plus 4x squared minus 33x plus 63. And then when you have squared, when something is squared and that's your highest power, equal everything to 0. So we subtract x and subtract 1, subtract x, subtract 1. So we have 0 equals 4x squared minus 33x plus 64. And now we need to factor, 63. Keep running to write 64 for some reason. Because this is supposed to be 64. There we go. Alright, so now we factor. So we have 0 equals 4x minus 21, x minus 3. Now we're going to set each of these equal to 0. So we have 0 equals 4x minus 21, and 0 equals x minus 3. So solve for x in both. I'm going to go fast through here. So we have x is negative 21 over 4, and x is 3. So we need to check our answer. Obviously, I'm going to check x is 3 first because that's the easy one. So we have 2x, which is 3, plus square root of x plus 1, so 3 plus 1 equals 8. So now we have 6 plus the square root of 4 equals 8. So it's 6 plus 2 equals 8. And that does indeed check out, so x equals 3 is a solution. Now we need to check negative 21 over 4. So we're going to plug it in. So we have 2 times negative 21 over 4 plus negative 21 over 4 plus 1 equals 8. I'm going to cross simplify here. So now we have negative 21 over 2 plus, so here we have negative 21 over 4 plus 4 over 4 equals 8. So keep going, keep simplifying. We have negative 21 over 2 plus I don't know why I keep putting negative. It's supposed to be plus. There we go. I have no idea why I put a negative there. Sorry about that. So we have 25 over 4 equals 8. Keep simplifying. We have 21 over 2 plus 5 over 2 equals 8. Now we have 26 over 2 equals 8. That does not equal 8. So 21 over 4 is not a solution. So our only solution is x equals 3. Alright, example 4. This is where we have 2 of them. So now that we have 2 of them, we need to isolate at least one of them. So we're going to isolate. It's already isolated, so we're good to go. Now we're going to square everything. So we have y plus 5 equals, we're going to square. So that's 2 minus the square root of y minus 4, and 2 minus square root of y minus 4. So we have y plus 5 equals 4 minus 2 times the square root of y minus 4 minus 2 times the square root of y minus 4 plus y plus 4. Combine like terms, so we have y plus 5 equals 8. And then we need to subtract the 8 and subtract y. So we have negative 3 equals negative 4 times the square root of y minus 4. Divide by negative 4. So we have 3 over 4 equals the square root of y minus 4. Now we need to repeat the steps again. Square both sides. So we have 9 over 16 equals y minus 4. Add 4 to both sides. So we have 9 over 16 plus 4 over 4 over 1 equals y. Get the common denominator. So we have 9 over 16 and that gives us 73 over 16. And if you check, it works. We're not going to do it for time purposes. Alright, example 6, we're skipping 1, like we did in class. So example 6, we need to isolate a radical. 1 already is. So we have 5x equals 25, divide by 5. So x is 5. Now we need to put it back in and check your answer. So we have 5 times 5 equals negative 5. The square root of 25 equals negative 5. It does not. So this is no solution. Alright, Pythagorean theorem. That's leg squared plus leg squared equals hypotenuse squared. So we want to find the length of a hypotenuse of a right triangle when the length of the two legs are 2 and 7. So we have our a squared, so 2 squared plus b squared, which is 7, equals c squared. So we have 4 plus 49 equals c squared. That leaves us with 53 equals c squared, square root. So the square root of 53 equals c.